2008-12B. 25 questions, of which I'll probably won't get to 10 of them, in 75 minutes. 6 points for every right question and 1.5 points per skip. I might get a pretty low score because it's currently 1:20 a.m., but it's fine. Hey, that's a playback of my own voice. Let's begin. Guess what I'll get? The cutoff is about 100 points, but it varies with every exam. Right, this is the first time I'll see this problem. Wait a dang second. I've taken this one before. Okay. Then we're moving to the 2008-12A, I guess.
2008-12A?
Yep. Don't mind this. Okay, now this is the first time. Oh my god. Okay, never mind. Wait, have I seen this? Yup, I have. Jesus Christ, I've taken every single damn thing. Okay, we're going to 2007-12B.
Let me know.
Jesus Christ. Okay. God dang it, I've done 12 before.
Why don't you take to something else? B.
This is the B. Let's go to A.
Or AMC 10.
Oh, the AMC 10 shares most of the problems from the AMC 12.
It doesn't matter.
No, it's
Okay.
it has the same
All
problems.
right. Just find one that you should have checked it before you come to live.
One ticket to okay, I haven't seen these before. Have I done these? Okay. I do not think I have seen this one before. Okay. We have traveled all the way back in time, a full year, to AMC 2007-12A.
Good luck.
All right. Finally. Okay. Problem 1. One ticket to a show costs $20 at full price. Susan buys 4 tickets using a coupon that gives her a 25% discount. Pam buys 5 tickets using a coupon that gives her a 30% discount. How many more dollars does Pam pay than Susan? All right, that shouldn't be that hard. 80 times 1/4, and then you're subtracting 100 times 3/10. We all know this is 7/10. Okay. We have 70 minus 80 over 4 is, okay, 70 minus 60. So Pam pays 10 more bucks. Oh, I should have made an answer sheet. 1, 2. 12, 13, 14, 15. Last night I couldn't get it farther than 15, so that's where I'll stop. And 1 has to be C. 2. An aquarium has a rectangular base. For some reason, this is a clickable link that measures 100 centimeters by 40 centimeters and has a height of 50. It is filled with water to a height of 40 centimeters. A brick with a rectangular base that measures 40 by 20 and a height of 10 is placed in the aquarium. By how many centimeters does the water rise? I know it's actually aquarium, but not aquarium, but yeah. So, let's see. 100 by 40 and has a height of 50. It is filled with water. Okay, so the volume of water in here is 100 by 40 by 40, which is 100 times 1600, which is 160,000 cubic centimeters. So now it's filled with, okay, so we're adding this to 40 centimeters by 20 centimeters by 10, which is 8,000 cubic centimeters, I think. And so we have 168,000, and now we're dividing it by the total area of the base, which should be 4,000 square centimeters. To get 168 over 4. So that means it rises by 2 centimeters, because this is 2 greater than the original, what was 160 over 4. So D. Okay. 3. The larger of 2 consecutive odd integers, so if we have x, then we have x plus 2, is 3 times the smaller. What is their sum? Okay. So the larger of 2 consecutive, that's weird. Okay. So x is equal to, 3x is equal to x plus 2. 2x is 2. Oh, so x is 1. So 1 plus 3 is 4, which makes it A.
Wow, very quick.
Well, this is problems 1, 2, 3. So my problem solving pace will slow down by quite a lot. Kate rode her bike for 30...
Make sure you write the problem number over there so people can... Solving 3, so write 3.
Okay. No, I'm solving 4.
Oh, you're solving 4, write 4.
Yeah, and it's on. It's over here and on here. Okay. Kate rode her bike for 30 minutes at a speed of 16 miles per hour, then walked for 90 minutes at a speed of 4. What is her overall average speed in miles per hour? All right. So what's the distance she covers over her time? So average speed is obviously just distance, which is 30 at a speed of 16 mph. That's 240 miles. Right? Oh, no. It's 8 miles. It's 8 miles. Because he drove for half an hour, or rode for half an hour. Then walked for 1.5 hours at a speed of 4 miles per hour. So that's 6, divided by the total time, which was obviously 2 hours. So that means it was 7 miles per hour. Also A. No, B's are E's yet. Last year, Mr. John Q. Public received an inheritance. He paid 20% in federal taxes on the inheritance and paid 10% of what he had left in state. He paid a total of $10,500 for both taxes. How many dollars was his inheritance? All right, so John Q. Public paid an inheritance, paid 20% in federal taxes on the inheritance. So, okay. So, that means that if he had X originally, he paid 20% in federal tax, so 0.8x of inheritance, so 0.2x leaves him, and then 0.1 times what he had left, so 0.08x. Which leaves him with 0.72x. And 0.28x is 10,500. What is x? Well, it's 10,500 over 0.28. Now the thing here is, this contains 105, and 105 is 15 times 7. So this is just 15 times 7 times 100. Over 28, this is 0.28. So, x is equal to 15 times 7 times 100 over 4 times 7 over 100. So, x is equal to 15 times 100 times 25, which is in total 2,500 times 15, which is 25,000 plus 12,500, which means that his inheritance was $37,500. D. See Dad. Okay, 6. ABC and ADC are isosceles with AB equals BC and AD equals DC. Oh, by the way, try solving these problems yourself. point D is inside triangle ABC. Angle ABC measures 40 degrees and angle ADC measures 140 degrees. What is the degree measure of angle BAD? Alright, so angle BAD, let's see. So ABC and ADC are, alright. So we have A and ABC and ADC are isosceles. So this is ABC and let's say this is ADC. Okay, point D is inside triangle ABC, okay. So it's a dart. So this is how D looks like. Angle ABC measures 40 and ADC measures 140. Okay, now that we've got a terrible diagram, we can draw a good looking diagram. This is A, C, B. This is 40 degrees. And we can put D up here such that this is 140 degrees. We know this is true, and so is this. What is the degree measure of angle BAD? Bad. Okay. What is this? Well, oh, yeah. So if I slice this in half, then, well, this whole triangle ABC is isosceles. This is going to be 70, so this is 20. This fellow's 22, because this is right. And then, when we have 40 degrees in an isosceles triangle being a vertex angle, then the other ones are going to be 70 degrees, so this is 50. Right? I mean, it seems correct, but I really am resisting picking D for the third time. Whatever, it's fine. See, Dad did the... Okay. 7. Let A, B, C, D, and E be 5 consecutive terms in an arithmetic sequence. And suppose that A plus B plus C plus D... Wait, 1 second. And AD equals DC? I'm sorry, I just need to AD... Okay, good. I was worrying about an assumption that I made. Okay. And suppose that A plus B plus C plus D plus E equals 30. Which of A, B, C, D, or E can be found? 5 consecutive terms. Well, they can all be found, no? X plus 1 plus x plus 2 plus x plus 3 plus x plus 4 equals 30. And another way to phrase it could be B minus 1 plus B plus B plus 1 plus B plus 2 plus B plus 3. Another way to phrase it could be C minus 2, C minus 1, C plus 1, C plus 2. Another way to phrase it is D minus 3, D minus 2, D minus 1, D, and D plus 1. And this way is E minus 4 plus E minus 3 plus E minus 2 plus E minus 1 plus E equals 30. So with all of these statements, well, let's see. Can't you find it from all of them? What do you mean? Which of A, B, C, or E can be found? What? I just don't understand what the question is trying to say here. Well, I mean, if it does us any good, I know that the terms are 4, 5, 6, 7, 8, right? 4 and 5 is 9. Yeah. 4, 5, 6, 7, 8. Wait, arithmetic? Why am I just assuming that? Okay. Well, why was I assuming that the common difference was just 1 all of a sudden? So that changes things. That means that instead of this, we're going to have to develop something generic. This is 5e, 4, 3, 2, 1, 10. Okay. Okay. D minus 3 plus D minus 2. Okay. So 5D minus 6. Okay, minus 5x. Oh! Wait. So that allows you to find D minus x, which has to be C. So it's C.
Wow.
Come on, it's only a tiny problem. 8. A star polygon is drawn on a clock face by drawing a chord from each number to the... Okay, so let's draw a clock. No. Wait, so aren't legs on its face? I'll think about that part later. 12, 3, 6, 9, 10, 11, 5, 8. Okay, so drawing a chord from each number to the 5th number counted clockwise. 1, 2, 3, 4, 5 from that number. Oh, so that's a common distance. That is, chords are drawn from 12 to 5, from 5 to 10, from 10 to 3, 3 to 8, and 8 to 12. Wait, what? Wait, from 12, wait, no. So that means it goes to 1, it goes to 6, which goes to 11, which goes to, what's 4, which should go to 9, which then goes to 2. No. Which then goes to 7. God, that's ridiculous. Which finally ends on 12. That's majestic. Oh, it's only asking for the degree measure. Phew. Okay. So, thought I was going to have to die for this problem. But it's fine, I guess. So if we have 6, then it's going to be connecting to both 11 and 1. The thing is that if this is 1/12 the radius, right? The 1/12 the circumference, right? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Yeah, okay. So that means that this distance right here is exactly 1/6 the circumference, which is 1/3 pi r. How does that help? Probably helps. Well, we can draw a dart. Darts are fun. This is 1/6. 6 of that is 60 degrees. What's the degree measure of this fella? Oh, this is just like the other question we had a while ago. Just phrased way differently. So, this is 60. This is 300 degrees. And we know these two are the same. Just gonna bisect this one. This is 150 degrees. So that means this is 15, this is 15. So it should be 30, which makes it C again. That's a little bit of a disturbing lack of B or E. 9. Jan is somewhere between his home and the stadium. To get to the stadium, he can walk home. Oh, let me have some of these. Come on, you didn't tell me that. Okay. Jan is somewhere between his home and the stadium. To get to the stadium, he can walk directly, or else he can walk home and then ride his bike to the stadium. He rides 7 times as fast as he walks, and both choices require the same amount of time. What is the ratio of Jan's distance from his home to his distance from the stadium? Okay, let's see. To get to the stadium, he can walk directly. Walk. Okay. All right. So, let's say this is the home and this is the stadium. Let's say they're both 1 kilometer away from each other. So Jan is somewhere on this line. And this is Jan. And he rides 7 times. Okay. So he can walk directly to the stadium. Let's say Jan's walking rate is equal to, okay, so you know Jan's walking rate is equal to some number x, and the rate of riding a bike is 7 times that. So that's probably important. So when he just walks to the stadium, let's call this a distance d, it takes him a time d over x. But when he goes home, this is 1 minus d over x. This is 1 minus d over x. And then when he goes all the way back to the stadium, 1 over 7x. So we know 7 times 1 minus d plus 1 over 7x is equal to d over x. Right. So 7 times 1 minus d plus 1, we can just remove the entire necessity of x here, which is great, because now we only have one variable in this problem, and that's exactly the one that we're looking for. 8 minus 7d equals 7d. So 8 is 14d, which means d must be 8 over 14, which is 4/7. So that means he's 4/7 of a kilometer to the stadium and 3/7 of a kilometer to home. So the ratio should be 3/4, which is B. Wait, where's the... Should I tell wie fast we've gone to problem 10?
Wow, I'm so fast, but it's okay. It's okay.
I want him to watch.
Only if we make the cutoff.
Oh, I want him to watch me do it.
After 12.
Sure. Problem 10. A triangle with side lengths in the ratio 3 to 4 to 5 is inscribed in a circle with radius.
Hey, Daph! Isaac is very proud of himself. He thinks he will make the cutoff. So come.
We're on problem 10! Okay, triangle with side lengths in the ratio 3, 4, 5 is inscribed in a circle with radius 3. What's the area of the triangle? No, I'm on problem 10. You want to watch?
I'm getting my GLE. What did you
Oh.
get?
Oh, he want you to solve the problem because he thinks you'll make it.
No.
Unlimited.
No,
What?
he want you to watch him solving.
No,
okay.
I have to.
Okay, so
Go.
let's see. 3, 4, 5. Okay. Okay, 3x, 4x, 5x. This doesn't necessarily have to be the diameter. Or does it? Isn't that what Thales' theorem says? I'll have to think about that. It's inscribed in a circle with radius 3. What is the area of a triangle? Wait. Okay. So, according to Thales' theorem, then 5x has to be the diameter. So, the diameter is 6. So, x is 6 over 5. So, the area is 18 over 5 times 24 over 5 times 1 over 2. So, it should be 18 times 12 over 25. Which means that it's gotta be, what's 18 times 12 again? 18 times 12, this is kind of, 180 plus 36 is 216. Okay, multiply that by 4 are respectively the hundreds and digits. Okay, so from the way I'm understanding this, when we have A, B, C as one term, then the next term is B, C, D. So it's like an assembly line or a conveyor belt of terms. Okay? It becomes C, D, E, and eventually the tens and units digits of the last term, so x, y, z, are respectively the hundreds and tens digits of the first term. So let's see. Okay. So that's how the sequence looks like. For example, such a sequence might begin with, okay, let S be the sum of divide S. Dear God. Okay. So, what can we do here? Aha. So, the sum of all these, let's see. So we have 100y plus 10z plus a. So that's yza. Then when we have zab, then we have 100z plus 10a plus b. And then it gets to ABC, so it's 100A plus 10B plus C, and so on and so on. So we see we have 100Y at first, then we have 110Z, then we have 111A, and then sooner or later, we're going to get 111B as well. We're going to have a multiple of 100 and 110 at the start, and then 111 all the way through. So what's the largest prime factor that will always divide? And, okay. And this is just how to express the sum. Not necessarily that the number at the beginning is going to be a multiple of 100. So let's see. Let S be the sum of all the terms in the sequence. What's the largest prime factor that always divides S? Oof, that's a tricky one. Well, let's try doing it. Oh. A little bit of trial and error. The sum of all the terms in the sequence. All right. So, let's think about the last term, by the way. I forgot about the last term. The last term is going to be 100x plus 10y plus z. So, it's going to be 110y plus 111z plus a plus b, etc. So would it not be 11? Apparently not. Does 13 really divide 110? It might divide 111, but I'm not sure about 110. Well, no, it certainly can't divide into both of them. So, well, we could say it's 111 times z plus a plus b, etc., plus y minus y. So it's any multiple of 111 minus this y. So let's say we, for example, take 1, I don't know. What's a probable one? I guess 11100 plus 111. That's reasonably big enough for me. So 11211. First of all, what's the prime factorization of 111? Does it divide into 3? Yes, it does. I'm pretty sure. Yup, it divides the 3 by a factor of 37. And 37 is another prime, so it ends there. So, if we have that, if y equals 1, it becomes 11210. Does that have 37 on it? What's the large factor that always divides s? It's tricky. So tricky that I might have to press skip. Integers a, b, c, and d, not necessarily distinct, are chosen independently and at random from 0 to 2007, inclusive. What's the probability that AD minus BC is even? Okay, there are several ways to make even numbers from subtraction. not several. There's odd minus odd, even minus even, and that's it. So what about how to make products? Because we have AD and BC, obviously. So you can have even. Odd times odd is odd. Odd times even is even. Even times even is even. I think that's all the kinds. Okay, so that means that if we want this, then we have all 4 odds. If we want this, we have this, or we have all 4 evens. So let's see. I chose it at random and okay. So now 2007 is even or odd. So I think only parity affects the probability that something's going to be even or odd. The parity of the starting and ending point, which is why we're going to test it with from 0 to 10 and 0 to 11. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many even numbers are there in that? Technically, I'm going to count zeros and even. So 1, 2, not necessarily. Okay, 1, 2, 3, 4, 5, 6. There are 6. And out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And out of here, 1, 2, 3, 4. And this one is 6 out of 12. Okay. Okay, so if it ends on an odd, then it's exactly half of all the numbers. How many numbers are there? 2008, 1004. So that means that out of 1004, we've got to have 502. But anyway, all that matters, it's 1/2. So now, well, not the answer, not specifically the answer. So we're looking for the probability that one of these two happens. But the easier thing to do is to look at the probability that one of these things happened. So odd times odd minus odd times odd. That's exactly what we're not looking for. So odd times odd, obviously there's a 1/2 chance of picking odd. So all 4 odds is going to be a 1 in 16 chance. Right? What is the probability that AD minus BC is even? Oh no, we're looking at both cases here. So the only case where we can't have is even minus odd or odd minus even. So here we have odd times odd minus, well, here we have even times even minus odd times odd. And for that, I mean, there's a, Okay, so there's a 1/2 chance that something is even, and 1/2 chance that what you get again is also going to be even. And also, the same way the other time. But the thing is, there are 4 possible indistinguishable ways you could arrange it if both of those products, both of the multiplicants that make the product, or the factors that make the product, have the same parity. So, A time, okay, right? Because Now 2. Yup. Okay. So you have 2 possibilities for how to arrange each one. So it should be 4 ways, right? Which means that there was a 1/4 chance of this happening. Right? And then the chance that an odd times even happens instead is the same thing. That means it should be 1/2, which means the answer should be C. Once again, there's a disturbing lack of the answer being E. 13. Excuse me. A piece of cheese is located at 1210 in a coordinate plane. A mouse is at 4, -2, is running up the line y equals -5x plus 18. The point AB, the mouse starts getting farther from the cheese rather than closer to it. Okay. So, here we have, 1210, so about here, but the x is slightly greater. So here's the piece of cheese that our mouse is mindlessly running towards at 1210. And the mouse is at 4 -2 and is running up the line -5x plus 18. So 18 is all the way up here, I'd presume. And then what's the the x-intercept of that? That's when x equals 18 over 5, which is about, what's 18 over 5? 3.6. So that means that we have 3.6, which is about, if we have here. So this is 3.6. And we're just drawing a line from one to the other. And we're seeing how far the mouse will run up the line. So it starts at 4, -2. And we're trying to optimize its distance to the line and to the cheese. So that would be the perpendicular. So it's the line with slope 1/5 that runs through 1210, I think. And where it intersects this is going to be our answer. So 12, 10. So 10 equals 12 over 5 plus B. This is 50 over 5. So B's got to be 38/5. And we need to know where 1/5 x plus 38 over 5 is equal to -5x plus 18. That's going to be our minimum distance to the cheese. So we have 26x over 5 on this side is equal to 90 over 5 minus 38 over 5. So 26x over 5 equals, I think that's 52. Yeah, it's 52, which is oddly convenient because this is a multiple of 26, so this is just 2. So x is 2, right? Then, at x equals 2, the y equals 8. So it should be B.
Wow.
All right, 14. Let A, B, C, D, and E be distinct integers such that, dear God, what is A plus B plus C plus D plus E?
Isaac, I want you to drink water.
Whoa! I just had an idea.
Oh, really?
Mm-hmm. When you think about it, that means we have 5 factors of 45 that are less than 6. Well, unless one of the integers was negative. So what are the factors of 45 exactly? Well, we have 1, we have 45, we have 3, we have 15, we have 5, we have 9. Is there anything other than that? Of it. So, and 5 of them are here. So, that means that there are 6 ways we could do this, right? So, there are 6 possible sums for A, B, C, D, and E. 3, 4, 5, and 6. So the first one is where we leave out 45. So then A is going to be equal to 5, B equals 3, C equals 1, D equals -3, and E equals -9. Alright, so what's the sum there? Well, 5 plus 3 is, wait. All of the sums are positive. Oh boy. So, what am I looking at here then? I could try, even prime factorizing it doesn't give that much. Okay. 45 is 5 times 3 times 3. Oh, I just realized some of them can be 0. So that means that A is 1, B is 3, C is, wait, distinct integers? Okay. That's a roadblock. There's no other way to make 9 other than combining. So my train of ideas is stopping there. 5 and 9 are the only ones that are in reasonable reach. I just realized something. A, B, and C could be, oh, wait, no. If A was 5, that wouldn't change the product. So let's let A be 5 for a second, just so we can mindlessly increase the sum. Then we're looking at 4 factors used just to make 9. That's not good. And if we set any one of them to 6, that's going to zero out the entire thing. We can't set any one of them to 5. The nearest one we can set one to is 3. So it's really not a very possible game to win, is it? How do you multiply 5 different integers and just get 45? 45 doesn't have that many factors. Just 3 times 3 times 5. Well, how do you multiply 5 things to get 45? You know what? I'm also going to have to skip 14. I'm gonna opt out. 15. The set 3, 6.
With this skipping, you still have chance?
I think so, maybe.
Okay. Can you bring it up?
Yeah.
Move it up.
Yeah. Oh, yeah. The set 3, 6, 9, 10 is augmented by a fifth element n, not equal to any of the other four, so distinct. The median of the resulting set is equal to its mean. Oh, that's not that bad. It can't be that hard, right? Well, okay. So what are all the possibilities? First we have n, 3, 6, 9, 10. Then we have 3, n, 6, 9, 10. We have 3, 6, n, 9, 10. 3, 6, 9, n, 10. And 3, 6, 9, 10, n. So what are the different medians? This one has 6 as the median. This one also has 6 as the median. This one has n as the median. This one has 9 as the median. And this one also has 9 as the median. Okay, so we know that the mean, well, the mean is, okay, a fifth element. Do we know that it's an integer? Probably not. Okay, so 6 plus 9 is 15, 18, 28. So is there any way 28 plus n over 5 can be equal to 6 without being equal to any of the other four? Well, 28 plus n equals 30 then, so n equals 2. So yes, this works for this scenario, not exactly for this scenario. They were mostly the same anyways, let's face it. Okay, this is gonna be also pretty weird, but we know 28 plus n is equal to 5n now, so that means n equals 7. So this is possible for n equals 7. When this happens, we know 28 plus n is 45. What's 45 minus 28? It's 17, right? So, not possible for this configuration, but it is here. So n equals 2, n equals 7, and n equals 17, meaning the total sum should be 26. E. Finally. The first E for the entire test. Jeez.
I think you deserve water.
No, it's fine.
Move it up.
How many 3-digit numbers are composed of 3 distinct digits such that one digit is the average?
So tell the audience,
The
if
other
you
two.
can solve one problem beyond 15.
Yeah, I'm pretty sure I can do it. I have 10, 11, 12, 13 problems solved.
So how many you have to solve beyond 15 in order to make the cutoff?
Probably 2.
So good luck.
Okay. 16. How many 3-digit numbers? After 15, we're really deep diving into the depths. We're really desperate. How many 3-digit numbers are composed of 3 distinct digits, such that one digit is the average of the other two? Okay, well, first of all, that means that those digits have to have the same parity, because the average of 1 and 4, for example, isn't very tidy. Also, what can we say? They are 3 distinct digits. So, we have some ideas. You can have, okay. So you want to have 2 distinct digits of the same parity. Okay, so we have 2 numbers between 1 and 9 inclusive that are of the same parity, and yes, okay. And also we have to consider the permutations and stuff. Okay. So when we have 2 numbers, if we pick out 2 numbers, how many pairs can we make with the same parity? Well, if we want a completely odd parity pair, then there are 1, 3, 5, 7, 9. So So there are 5 ways and 5 ways again. Well, no, 4 ways because we're thinking of picking 2 distinct ones. Same logic applies for the evens. We have 2, 4, 6, 8, and technically 0. Oh, I just realized we also have to. Oh God, that's not good. Okay. We technically have to contend with 0, but maybe, exactly, maybe? Yeah, okay. We have to contend with 0. That sucks. So we have 5 times 4 for this one, too. So that means there are 40 possible parity pairs. So once we have 40 possible parity pairs, we want one digit that's the average of the other 2. So, okay. So this is strictly without considering the ways that you can arrange them. Now, for each pair, you can only arrange them 2 ways, which only makes 80, no?
Shubham, what number are you on?
16.
Good night. I'm too sleepy.
Good night, baby.
All right.
Isaac, Raf, come take a kiss from dad.
Jeez.
322.
322, Jane. Alright, good night, baby.
Dear God, help me.
I help you.
If he get above 100, I'll work you up.
So you can tell him.
Shut up. Let me undo the key. Let me undo the key, sir.
This is conflicting, such that one digit is the. Okay. And then it gets even worse because you have to subtract the. Oh, I just realized there are 3 different. Oh gosh. So we multiply 40 by 6 to get 240, and then we subtract the 0 cases. So, what are the 0 cases exactly? Well, they're all the cases where we have a 0 in front and some other random numbers in the back. That's why I did not want to contend with 0, because that isn't quite a 3-digit number. That's invalid. So, if we're removing all possibilities which specifically have 0 as the first digit, that would be like 20 possibilities, maybe? Well, okay, how many pairs have 0? Then, if we want to make a pair that has 0 for one, and then an even number for the other, we have 1 times 4. So there are 4 possible pairs that contain 0, and there are, and if we want to do it such that 0 is in front, then there are, okay, so it should be like 240 minus 8 or something. No? All right. I'll have to wager C. I don't feel good about picking C, but I'll have to wager C.
Wish you good luck, baby.
Really hope that's correct.
Move it up.
17, that's a trigonometry problem. I'm not even going to acknowledge that. 18, polynomial x to the, oh God, it's imaginary. I'll try, has real coefficients, and f2 of I equals f2 plus I equals 0. Okay, so okay. I'll try, I can try.
Make 1 beyond 15, then that's guaranteed, right?
Maybe.
Good luck, baby.
So if I plug in 2i to this gargantuan of a function, we get 2i to the 4th plus a times 2I to the third plus b times 2I to the second, which is just squared, c to the 2, okay. Okay. And so 2I to the fourth is just 16. A times 2I to the third is minus 2AI, because I to the third is minus I. Plus b to the 2I squared is going to become minus 4b. Because, you know, I squared is minus 1. And then plus 2ci plus d equals 0. Okay. So that means minus 2a plus 2c must be equal to 0. So a plus c, or minus a plus c is 0, and a equals c. Okay, that's good to know. What else do we know? 16 minus 4b plus d equals 0, which doesn't let us make any direct statements, but it's also helpful to know. And we need to know what a plus b plus c plus d is. Aha. And now we have the other critical piece of information, the 2 plus I. F of 2 plus I is 0. Now, surely this will be harder to plug in, because I'll have to distribute, well, not distribute, but I'll still have to write out the whole binomial theorem thing. So, what does the binomial theorem say? 2 to the fourth plus 2 to the third I plus 2 to the second I squared plus 2I cubed plus I to the fourth. And then we have plus a times 2 cubed plus 2 squared I plus 2I squared plus I cubed plus b times 2 squared plus 2I plus I squared. Is that right? No, it's not, is it? Because if I do 2I, 2I, 4, 2I, 2I, yep, okay. So is my 3-digit one from the binomial theorem even right? 2, wait, no. Oh god, I'd have to make a cube for that. Well, you can do this with 4I and I squared, and then 2 and I. Okay. Okay, it goes wrong. So, really don't want to have to do this, but I'll have to distribute using the box method like a little moron I am. Now, thinking about this, no, this is just minus 1, right? So, this is minus 16. That's good. I and 4I, that's just minus 4. I and minus 1 is minus I. So, 12I, 11I, and 11I minus 12. Okay, so when we take 11I minus 12 and multiply it by 2 plus I, what do we get? 22I minus 24, and then minus 11 minus 12i, which leaves me with 10i minus 35. Alright, we have something to work with. 10i minus 35 plus a times 11i minus 12 plus b times 3 plus 4i plus 3 plus c times 2i plus 2 plus d. And this is equal to 0. So we know 10i plus 11ai plus 4bi plus ci, and then we have, okay, so 10 plus 11a plus 4b plus c equals 0. That's great. Okay, second up, we know that minus 35 minus 12a plus 3b plus 2c plus d is equal to 0 as well. So that's also so cool. Super cool. So we have this very weird looking system of equations. My first instinct is to add everything together like a little caveman I am. Maybe there's something beyond the surface. Okay. Well, let's add them together. We get minus 25 minus a plus 7b plus 3c plus d equals 0. Now let's incorporate this fella into that. You get minus 9 minus a plus 3b plus 3c plus 2d equals 0. It's like we're so painfully close. 20 looks very appealing. 19 does not look very appealing.
You are very close, baby.
I feel very close.
Come on, baby.
Oh, yeah. And I remember the fact that A equals C. Probably should have paid attention to that before. Minus 9 minus A plus 3B plus 3A plus 2D equals 0. Please say this will simplify our situation. Nope, it makes it worse. Okay, so minus A plus 3B plus 2A plus 2D. $16 is 4b minus, okay. So D is just 4b minus 16. 4b minus 16. Minus 9 plus 3b plus 2a plus 2 times 4b minus 16. So 8b minus 32. Okay, come on, come on, come on, come on. 11b plus 2a minus 9 minus 32. What's 9 plus 32? It's 41, right? So equals 41. Jeez, mate. Jeez. The last thing I need to do is develop a relationship between A and B in terms of some number instead of a bunch of meaningless variables. That might have been the hardest thing to do thus far. Okay. Let's think about it. Let's see. I'm really trying hard to snag something out of this. 11b plus 2a.
Sorry, baby.
It's fine, it's fine. Well, given that these are all integer sums, I'm going to make the blind assumption that they are all integers, even though that's probably not going to lead me anywhere. Then that leads to 41 minus 33 or 41 minus 11. Then in that case, b equals 3 and a equals 8. And in this case, b equals 1 and a equals 15.
Good luck.
Okay. If we know that d is 4b minus 16, then d could be minus 12, and c is equal to a. That is 15. So 31 minus 12, 21 minus 0, 19. That's not an answer. Let's move here to the other one. 11b plus 2. Okay. So if a equals 8, c equals 8, and b equals 3, so d is 4b minus 16, which is minus 4, which is 16. 16 minus 1. Okay. I'll have to guess. And I have one final one that I want to try before I go.
Alright, ready? Good luck.
19, I'm not going to even look at. 20. I just took
I want you to drink a little bit of water.
Nah. Okay. Corners are sliced off a unit cube such that the 6 faces each become regular octagons. What is the total volume of the removed tetrahedra? Okay. So that means we have something that looks like this. And that. So we've removed this little tetrahedron off here. So the 6 faces each become regular octagons. If I have a unit cube, how do I slice it such that it becomes a regular octagon? S over root 2. Well, that would make root 2s plus s equal to 1. So 1 over 1 plus root 2. So now we have to envision I think the area of a pyramid is like, and this is just a triangular pyramid, no? 1/3 times the height. This is still a problem, but I'm sure I can solve it. And then the area of the base. And so that's s squared root 3 over 4. S is just going to be a variable that's going to be referring to this value right here. So now I'm pretty close. Okay. So now how do I find the height here? What's the height of this? This is really not where I want, the kind of place that I want to be stuck on. Well, I can use the circumradius of a triangle. What's the circumradius of an equilateral triangle again? Is it equilateral? Yeah, it has to be. Okay, so here's the problem. Okay, so let's try finding this thing in terms of its side length. So if we have s over here, then this becomes 0.5s, and this is 30, 60, 90, so this is just going to be s. Huh? No. Wait, no. This length is 0.5s, so it's 1 over root 3s. So that's this part, also known as root 3 over 3s. And then we have this part, which is just going to be s. So s squared minus 3 over 9s, I swear, s squared, I swear I'm about to cry right now, is equal to x. So that means that, okay, this is 2/3 s. That's good news. That's good news. Good news. Okay. So now I think we've got everything on the assembly line ready to go. 1 over 1 plus root 2. 1 plus 2 root 2 plus 2. Okay, this is stressful. Root 3 over 4 times 2 over 1 plus root 2 times 3. Okay, just gotta simplify this thing, whatever I can call it. Okay, 3 times. Wait a second. Wait a damn second. We have 18 over here times 1 plus root 2. And then we have root 3 over 1 plus root 2 squared. So, I was thinking is that we can just do this. Root 3 over 18 1 plus root 2 cubed. Sure, this is going to take a lot of weird rationalization steps. Okay, all of them have denominators of 3. That's good. Because now I'm going to see I can multiply them by 1 over 6. 1 over 6 gives me root 3 over 6 over 3 times 1 plus root 2 cubed. I really don't want to have to do this, but I'm going to have to resort to estimation. There's really no realistic way to do this with the way I have. So, have to estimate. We'll estimate 1 plus root 2 is 2.5, in which case the cube of that is, what's the cube of 2.5? Well, the square is 6.25. Multiply that by 2, it's 12.5. And to multiply that by 1/2, it's 3.125. Which gives me for the cube 15.625. So, if we have 3 times 15.625 over root 3 over 6. Oh, God. I can't do anymore.
Sorry, baby.
All right. I really hope the cutoff was low because, yeah.
The test is kind of difficult, right?
Yes. Okay.
What is the cutoff?
Well, I don't know. We'll see soon.
Alright. Good luck, baby. You're gonna use it.
Cross fingers.
Cross fingers, yeah?
CDAA. Come on, with the first 4 questions. DDCC. BA skip. 12 P's. B C E.
Wow!
E.
Wow!
Oh no, that's not good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, no. 10, 11, 12, 13.
Don't forget to add the skip.
Plus 1 skip, 2 skip, 3 skip, 4 skip, 5, 6, 7, 8, 9, 10 skip. And that's a total final score of 93.
Wow!
I really hope the cutoff was low. Okay.
Let me see.
AMC historical go. Results. $20.10, $20.08, $20.07. Alright, ready for the big reveal? I think this is A. Ready? Ready?
Yes.
3, 2, 1. Amy floor. 97 and a half.
Oh my God, you almost got it.
4.5 points.
Almost got it, baby. So proud of you. So proud of you. So proud of you.
Thanks.
Well, you have 4 more months.
Yeah.
4 more months
Oof.
to break the record of talent style.
That was good.
Alright, baby. And you want to say any final word before we let you go?
No, it's fine. Thank you everybody for watching, and we'll see you in the next one.
Yeah, sure. Absolutely.